All right, guys, welcome to the Unit 3 test study guide. As usual, you're doing the even ones. I'm going to do them too, so you can check your work with me. And also, I've included the odd problems so you can have some extra practice, check your answers on the answer key provided. So let's go ahead and start off here with number 2. The first few problems are solving absolute value equations. And when you're solving these, the first thing you want to do is get rid of the numbers that are outside of the absolute value bars. So my first thing I'm going to do is add 10 on both sides, which will leave me with the following. Then I want to get rid of that 10 that's in front of the absolute value bar, so I'm going to divide that on both sides. And if the absolute value of r is equal to 10, well, there are two numbers that have an absolute value of 10. That means r can be negative 10 or r can be a positive 10. And that would be the solution to number 2. Let's go ahead and take a look at number 4. All right, so for number 4, there are no numbers outside the absolute value bars. So if the absolute value of p plus 6 equals 4, then we can say that p plus 6 is either equal to a negative 4 or p plus 6 is equal to a positive 4. So we start right away by writing two equations because there were no numbers outside the absolute value bars to get rid of. Now that we have two equations, we're going to solve both of them. For this one, I get negative 10. And for this one, I get negative 2. All right, so there would be our two solutions for number 4. Let's take a look at number 6. So in this particular problem, we have a couple of numbers outside the absolute value bars. I'm going to start by getting rid of those. Minus the 8 first. And the 6, we're going to divide it. And as soon as you got rid of the numbers outside the bars, you're ready to write your two equations. If the absolute value of 9a minus 5 is equal to 5, that means that 9a minus 5 can equal 5 or negative 5. So we'll go ahead and write those out. All right, and then we just got to solve both equations. So I'll go ahead and work through that real quick. So for this one, I get 0. And for this other one, I'm going to get 10 over 9. And there's our two solutions for number 6. All righty, move on. So for the next few questions, we're going to be graphing absolute value equations. Absolute value equations have a number in front of the brackets there. You have an h value, k value. These two things put together here are what make up our vertex. The k will stay exactly as it is, but the h will always be an opposite sign from what it is in the equation. So up here, since it's a minus h, I'm going to put a positive h. But likewise, if this was a plus h, I would put a negative h down here. So it's always going to be the opposite of whatever it says. But the k is not like that. The k stays exactly the same. This number here is our slope. Okay, so if you have a positive a, then that means you're going to rise that much and then run to the left and right. That way, when you connect your dots, you get your V shape. Whereas if it's a negative slope, you're going to go down and you're going to run left and right. And you'll still get the V shape, but it'll be upside down. So that's the difference there. All right. And sometimes you have missing numbers. If you're ever missing the A value, it would be a 1. If you're ever missing a H or a K value, those would be zeros in that case. Let's go ahead and jump in here and see what we're looking at. So for this first problem, I don't see my A value, so that means it must be a 1. So I'll put a 1 there. I also don't see my K value, so that must be a 0, which means that my vertex is going to be a positive 3 because I changed the value of the H, and a 0 for the K. My slope is a negative 1 over 1, which means that I'm going to go down 1 because it's negative, and I'm going to run left and right 1 space. So let's go ahead and graph to begin with. My vertex is over 3. up none. So there's my vertex, 3, 0. So that takes care of that. Now we're going to do our slope. And just as I said, we're going to go down 1, and then we're going to run 1 to the left and right, and we'll put a dot on each end there, and that gives us our absolute value function graph. All right, let's go ahead and take a look at number 10. Here's number 10. So on number 10, we're just missing our k value, so that would mean it's a 0. My vertex is going to be negative 1, 0, because we changed the value, the sign of the h, so it's going to be a negative 1 instead of a positive 1. K is just 0. And then my slope here is negative 3, so I'm going to be going down 3, and then left and right 1. Okay, so let's go ahead and begin. Negative 1, 0 is located right there. And then my slope is down 3, left and right 1. So if I go down 3, left 1, put a dot, and right 1, put a dot, we've got our V shape. That's our absolute value graph for that one. Let's move along to number 12. Now, number 12 has the situation where you have a number here in front of the x. And when that happens, we have a little bit of extra work to do. So let's be ready for that. First of all, we'll notice that I'm also missing my k value, so I'm going to put a plus 0 there. Now, the first thing we have to do when there's that 2 in the front is we have to divide that 2 out of the whole expression. So if I divide 2x by 2, I'm left with x. And if I divide 4 by 2, I'm left with 2. So we divide the 2 out. It's like the reversal of distribution. Instead of multiplying in, we're dividing out that number that's in the front. Now the next thing I'm going to do is I'm going to separate that 2 from the absolute value of x plus 2. And I'm going to take the absolute value of 2, which is 2. And the absolute value of 2 is 2, and I multiply that by 3, and I get 6. So we have to do that before we even begin. Now that I've done that, I can see what my vertex is. My vertex is going to be negative 2, 0. And the slope is going to be 6. So that means I'm going to rise 6, and I'm going to run left and right 1. So let's go ahead and graph and see what that looks like. Left 2, 0, that's my vertex. Next, I'll do my slope. So I'm going to go up 6, and I'm going to run 1 to the right, and I'm going to run 1 to the left. Should have this really skinny looking little V shape there. All right, let's take a look at number 14. Got another one of these ones with a number in front here. So here we go. First thing we're going to do is we're going to divide out that negative 1/4. Now, if you divide negative 1/4 out of this, you're just going to be left with the x. But how do you divide 2 by negative 1/4? Well, don't be afraid to show your work on the side. 2 divided by negative 1/4. We do same, change, flip. And then we just multiply straight across, and we get negative 8 over 1, which is just negative 8. So that's what's going to go there. All right, next we're going to separate that number we pulled out from the rest of the expression. Now the absolute value of 1/4 is, or negative 1/4, is positive 1/4. So that becomes positive after you take the absolute value of it. And then we need to actually multiply these. And 4 times 1/4, well, that's 4 over 1 times 1 over 4. You multiply top times top, bottom times bottom. You get 4 over 4, which is just 1. And so we're left with 1 there. And now we're ready to graph it. My vertex is going to be 8, negative 3. The h is negative 8, so I change it to a positive 8. The k is negative 3. So my vertex is 8, negative 3. So let's plot that over 8, down 3. Right there's my vertex. My slope is 1, so that means I'm going to rise 1, and I'm going to run left and right 1. So going up 1 running one to the right, running one to the left. We'll put a dot there, and there's my absolute value of that particular function. All right. Let's go ahead and take a look at number 16. For the next few problems, you're going to want to have out those two charts about vertical and horizontal transformations, which I gave to you guys in your 3.2 notes. So you might want to have those out. Go ahead and get started here then with number 16. So we have this function up here, f of x, to begin with. It's an absolute value function. And g of x is a transformation of that function. And the transformations can be found by finding anything that's different about this function than this one. So for instance, this one has a 2 in the front. And it also has a 2 being added inside the brackets there. So both of those are some kind of transformation to the function of f. So let's begin. Well, when you multiply a number outside, that's going to be a vertical transformation. And so we would look on our vertical transformation worksheet and we'd find where are we multiplying a number that is bigger than 1. And on your sheet, you should see that that is a vertical stretch. And the word expand is a synonym for stretch. So there's one. And I don't see any other options here that say that we're expanding vertically. So D is going to be the answer. But we can still look at the other part of it. Plus 2 inside the brackets is a horizontal change. And when you add a number inside the brackets, it's a translation to the left. So the answer is D for number 16. Let's go ahead and take a look at number 18. All right. For number 18, I can see our transformations are, we have a 3 here, and we also have a plus 1 here. Now, whenever you have a 3 being multiplied inside the parentheses, since 3 is bigger than 1, that would be a horizontal compression. And once again, I only see one option here that gives me a horizontal compression. So this must be the answer. The plus 1 is outside the parentheses. So that's a vertical thing. And when you add 1 outside the parentheses, it's a translation up. So the answer to this one would be option B. Let's go ahead and take a look at number 20. Different kind of question here. It's like the reverse of the question I asked a second ago. The last one I gave you the function and then the g function and asked you to explain what the transformations were. On this one, I give you the f function. I give you an explanation of some transformations, and you have to find the equation that would describe that. So here we go. Let's begin. So my first thing I want to notice here is that we're looking for a horizontal compression. And what that means is when you have a horizontal compression is that means you are multiplying by a number that is bigger than 1 inside the parentheses. So let's go ahead and take a look down here. Where are we multiplying by a number bigger than 1 inside the parentheses? Well, I have one here, and I've got one here. Okay. Now, we want to look at the other transformation that's present. They also tell us that we're translating down. Now, translating down means that we are subtracting a number outside of the parentheses. We're subtracting the number down outside the parentheses. So let's see if we can find where that one would be located. So out of these two options, which one has a minus outside the parentheses? That would be this one. And therefore, we know that D must be the answer. Let's go ahead and take a look at the next one here, number 22. So here I've got my x squared. We are expanding it vertically. And what that means is it means that we are multiplying by a number bigger than 1 outside the parentheses. I know that it's outside because we're talking vertically. Expansions, and I know it's multiplication because expansions and compressions our multiplication problems. And I know that it's an expansion instead of a compression because when you're doing outside the parentheses, it's when it's bigger than 1. So there's all of our information that we need. So I'm looking for where I'm multiplying by a number bigger than 1 outside the parentheses. Let's see. I see one here, and I see one here. Okay, there's 2 of them. Let's keep looking. We also want to be reflecting across the x-axis. Okay, now when you reflect across the x-axis, that means you're going to have a negative outside the parentheses, and that would be this one here. So we can see once again that the answer is D. Go ahead and take a look at number 24. So for this one, you're given 2 graphs, and your job is to find out if the blue one here represents the function of f and the green one represents g, what would you have to do? What transformations would you have to do to this blue line to make it look like the green line? And when we went over this particular lesson, I even had you guys write that question out. You don't have to do that, but it might help. But just keep that in mind. The question we're really answering here is, what do we have to do blue line to get the green line? Now on your test, they won't be colored. They'll be solid and dashed. So instead of saying, what do we have to do to the blue line to get the green line, we would be saying, what do you have to do to the solid line to get the dotted line? But that being said, let's go ahead and begin. So one thing I notice is that it's been flipped upside down. I would have to flip this blue line upside down in order for it to look like that. And when you flip it upside down, that's a reflection in the x-axis. And when you have a reflection in the x-axis, that means you have a negative outside the parentheses. Okay, so let's look at our options down here and see which one of these has a negative outside the parentheses. I see 3 options here, 1, 2, and 3. So I know that it can't be A, but we still have B, C, and D to look at. Now, something else you might notice here is that this green line is also a lot skinnier than the blue line. So just flipping the blue line upside down isn't going to be enough. We would also have to somehow make it look skinny like that. So we talked about how in order to make a function look skinny, that could mean one of 2 things. It could either mean that we had a horizontal compression or we had a vertical stretch. But either way, what it means is that we are multiplying by a number bigger than 1. And it could be inside or outside the parentheses. So since my graph looks skinny, that means we are somewhere multiplying by a number bigger than 1. And out of these green options here, this is the only one that's multiplying by a number bigger than 1. The other 2 are less than 1. And so once again, my answer here must be D. Let's go ahead and take a look at number 26. All right, so for number 26, what would I have to do to the solid line to get the dashed line? Well, one thing is I would have to flip it over once again. So once again, we're going to reflect it across the x-axis. And whenever you do that, what that means is that you're going to have a negative outside the parentheses. So let's find all of our options here where we have a negative outside the parentheses. So I see one here and here. So we have 2 options. But I also see that it looks like not just flipping this blue line upside down would make it be like right about here, but it looks like it's been shifted to the left 1 space as well. So it's also been shifted, or I should say translated, to the left. And whenever you're translating to the left, what that generally means is that you have added inside the parentheses. So we're looking for a place where we have added inside the parentheses, and that would be this one. And so, once again, the option is D. All right, let's go ahead and move on here, number 28. So now we're switching gears here. We're all done with the transformations. This one is asking me to rewrite this absolute value function as a piecewise function. All right. Well, to do that, it's not too bad. All we have to do is take this expression, and I'm going to write it twice. But when I do that, I'm not going to have absolute value bars anymore. I'm going to put parentheses. And for the one on top, I'm going to change the sign. So the sign is supposed to be a -3, but I'm going to change it to a +3 on the top. This side will always look like this, but this number will change depending on the problem. The number that goes there in that blank is the opposite of whatever's right there. Now in our lesson, we explained why all this is, but for now, we're just reviewing how to get the answers. Okay, so just so you guys know, you're going to need to simplify these. So you're going to have to distribute and combine like terms. So on the top, if I distribute the 3, I'll get 3x plus 6 minus 5, which is going to become 3x plus 1. On the bottom, if I distribute, I'm going to get -3x minus 6 minus 5, which is minus 11. These parts will stay the same. And here's our final answer. Okay, and what this is, we're just changing this absolute value function, which would look something like an upside down V shape. You can write it as a piecewise function, in which case, instead of thinking of it as one function, which is what this thing is doing, you can think of it as two separate functions, one linear function on the left side and a different linear function on the right side being put together. Okay, and that's what it is. Now you might think, well, that's kind of silly. Why would we even bother doing that? Because in calculus, that's very helpful. And this class is all about getting you ready for calculus. All right, number 30, same question, but we have a little situation that we need to deal with here first. Anytime we have these absolute value functions and there's a number in front of the x, we got to take care of that. So before we begin the similar process that we just went through on number 28, we actually need to go through and take that number out of there. So that -3, I'm going to factor it out of those two terms. So I'm going to divide this by -3, and that's going to leave me with x. I'm going to divide this by -3, and that's going to leave me with -2. After I do that, I'm going to take the absolute value of that -3 separately, which makes it become +3, and then this negative comes down, and then the rest of it comes down also. So we have to do that before we start transforming it into a piecewise function. All right. Now, here we go. I'm going to rewrite the expression now with parentheses instead of absolute value signs twice. But for the one on the top, I'm going to change the sign. This side will always look like this. The number that goes here will always be the opposite of whatever is here. And that's 2. And then from there, we're just going to simplify it. So distribution and combining like terms, -6 plus 2 would be -4. Distribution, combining like terms, gives us our final answer. All right. Got another one, but this time we have a fraction to deal with, and those always make things a little interesting, don't they? So the first thing we're going to do is we're going to factor out that number in the front, which this time is a 1/2. So if I have, actually it's a -1/2, so I better put my negative there. So if I divide this number here by a -1/2, I just get x left over. If I divide this by a -1/2, well, you might not know what that is, so let's do it. 3 divided by -1/2 can be determined by doing same change flip. Thinking of that as 3 over 1, top times top, bottom times bottom gives me -6 over 1, which is just -6. And so that's what's going to go right there is -6. So after you factor out your -1/2, you can take the absolute value of each piece. The absolute value of a -1/2 is +1/2. And 1/2 times 4 is 2. So now we've got it in the proper format. Now I'm ready to rewrite it as an absolute value function. I'm sorry, not as an absolute value function. I'm going to rewrite it as a piecewise function. So we rewrite the function twice with parentheses instead of absolute value bars. And we change the sign of the one on the top. This is always the same, but the number that goes here is whatever's right here, but the opposite of it. So it's going to be a positive 6. Distribution gives me negative 2x plus 12. And distribution on the bottom gives me 2x minus 12. And there's my piecewise function. All right, let's go ahead and take a look at number 34. So in number 34, we're being asked to sketch a graph of this thing here. I'm going to make it a little bit bigger. All right, so to graph these, the first thing we're going to do is we're going to pick some x values in this interval. So I want to pick some x values that are less than negative 1, but we do have to include negative 1. We always include the boundary point. And I like to always pick 3 points. So negative 1 is where I'm going to start, but now I want to pick some numbers that are less than that, like negative 2 and negative 3. The next thing we do is need to find the y values that go with these x values. And you find that by plugging this number into the function here. But as you guys can see, there's no x. Now, when there's no x there, what that means is basically that's always going to be the y value. So in this case, my y value for every one of these points is going to be negative 2. So I'll just put that in there now. We're going to repeat that process down here, but actually before I do, we want to put our points here. So this boundary point, I'm calling it the boundary point because that x value is the one that we started with. Since there's no equal sign underneath of there, we're going to be having a open dot there. These other two are closed dots, but it's just going to keep going after that. We didn't have to stop at negative 3, I just chose to. So basically we're going to start here and there's going to be an arrow going on after that. All right, let's do the next one, same thing. We're going to pick 3 points, and we always start with the boundary point. So my boundary point is negative 1 once again. But this time I want to pick numbers that are greater than negative 1. So that would be like 0 and 1. Now, this one, finding the y values, will be a little bit more interesting. We are going to plug in our x values. If I were to plug in negative 1, I would get, erase some stuff here. If I plugged in negative 1, I'll show my work for the first one. That would be 1 minus 1, which is 0. So if I plug in negative 1, I get 0. If you plug in 0, you'll get negative 1. If you plug in 1, you're going to get 0 again. Now, once again, for our boundary point, we need to identify, is it an open dot or a closed dot? My boundary point, negative 1, has an equal sign on its inequality, which means that it's going to be a closed dot. These ones will also be closed dots, but once again, it's just going to keep going after that. Okay, so we're ready to graph, so here we go. So let's start with the ones on the top here. I'm going to start at negative 1, negative 2. That's right here. And I'm going to use an open dot for that one. That takes care of that point. Let's move on to the next one. Negative 2, negative 2. It's right here, closed dot. And then let's do the last one. Negative 3, negative 2. That's right here. And starting at the boundary point, we draw a line through it, and then we let an arrow keep going to the left after that. Going to graph the next pair down here now. Negative 1, 0 is right here, and that's going to be a closed dot this time, and that takes care of that one. 0, negative 1 is right here. That's another closed dot. And then 1, 0 is right here. And we're going to connect those 3 dots with this bending shape, and it just keeps going after that. We started our boundary point, right? And then we keep going after that. And so that's what that particular graph would look like. All right. So for this last example here of piecewise function graphing, we have 3 pieces, And because of that, we'll just have to do a little bit more work. Something a little different happens in the middle here as well. So let's go ahead and see how this pans out. Once again, we're going to pick 3 points for the first equation, starting with -3, and then after that, picking numbers that are less than that. Now, plugging those numbers in, I'll show you my work for the first one. If I were to plug -3 into there, we would do the parentheses first, and then we would square it. So I get 1 for that one. If we continue to plug in the rest of the numbers, let's see what we get for those. Plugging in -4, I would get 0. Plugging in -5, I would get 1. Now, for the boundary point here, -3, you'll notice that it is a equal sign on the inequality there, and because of that, it will be a closed dot. These other dots will always be closed, and the last one will put an arrow after it just to indicate that it does keep going after that. Let's repeat the process for the middle row. So what's different about the middle row is the fact that there are 2 boundary points, and we have to include both of them. So I'll put the -3 on the left and the +3 on the right, and in the middle, we're going to pick a number between those, which I'll just go ahead and choose 0. All right. So once again, we're just going to plug these numbers in. So if I were to plug in -3 here, the double negatives would become a positive, and 3 minus 3 would be 0. If I were to plug in 0, I would end up with -3. And if I were to plug in a +3, I would end up with -6. Now, another thing when you're doing these double-sided boundaries is you're going to have to decide what kind of dots they are. So for the -3, it's an open dot. And for the +3, it's an open dot, because neither one of them have the equal sign underneath of the inequality. The one in the middle, though, will of course be a solid dot. And then finally, usually we have an arrow on the last one, right? But with these double bounded ones, it has endpoints on both sides. There's not arrows on both sides for these. All right, last one. Once again, we're picking 3 points, starting with 3. And then after that, picking numbers that are greater than 3, 4, and 5. And then we're going to plug these numbers in. So if you were to plug 3 in there, the absolute value of 3 is 3, but there's a negative in the front, and so the outcome will be -3. The next one will be -4, and the last one will be -5. In this case, my boundary point 3 will be a closed dot. The other dots are closed, and the one on the end has an arrow. All right, so we are now ready to graph our function. Here we go. So let's go ahead and begin by graphing this one on the top here first. So I'm going to do a solid dot at -3, 1, which is right here. Another solid dot at -4, 0. And then another solid dot with an arrow at -5, 1. And then I just connect the dots. All right. Let's go ahead and do the middle piece now. For the middle piece, we're going to have an open dot at -3, 0. We're going to have a closed dot at 0, -3. And then we're going to have an open dot at 3, -6. And in this case, there's no arrows, so we'll just connect everything with a line. All right, and then lastly, we have this. So I'm going to have a closed dot at 3, -3. another closed dot at 4, -4, and then another closed dot with an arrow at 5, -5. And there's my piecewise function. All right. Okay, let's go ahead and move on to number 38. So use this given piecewise function to answer the questions that follow. So to evaluate a piecewise function, that means we're plugging a number in for x. You have to know which piece to plug it into. And the way you know which piece to plug it into is by looking over here. So we have to ask ourselves, where is this number located? Is -2 less than or equal to -2? Is it between -2 and 3, or is it greater than 3? Well, -2 is equal to -2. So here's our winner, which means we'll be plugging the -2 into the top piece. So the top piece is x squared plus 3x, and the x value I'm plugging in is -2. So that would be 4 minus 6, which is -2 is my final answer there. So you have to look at the x value they give you, decide which piece it goes into based on these things on the right side. Let's go ahead and take a look at another one here, number 40. This time I want to do f of +2. Now, where is +2 located? Is +2 less than or equal to -2? Nah. Is it between -2 and +3? Ding, ding, ding. Yes, it is. So that means I'm going to be plugging this 2 into the middle equation this time. So 5 minus x is going to be 5 minus 2, and therefore that would be 3 is the final answer. Let's go ahead and take a look at one more, number 42. We're looking for f of 6. So where is 6? Is it less than -2? No, it is not. Is it between -2 and 3? No, it is not. Therefore, it must be greater than 3, and sure is. So that means we're going to be plugging the 6 in here. Now, there's no x to plug into here, but that's okay. That just means the answer is 8 no matter what. So our final answer is just 8. All right. And that does it for our study guide and review, and I hope that was helpful, and we'll see you guys in class.